Welcome to Industrial PLC Application, and this video is on MCR, Master Control Relays. Many industrial applications include the integration between many pieces of equipment or other machines. Therefore, it is important to make sure all the equipment works together. To accomplish this, many establishments use two forms of control: power distribution and control distribution. With power distribution, each load is connected with its own disconnecting means from a common splitter or power bus. Startup and shutdown procedures allow for individual machine cycle starts to be made and allow for individual power control and lockout tagout. However, since machines may be interconnected, a method of sequencing them or ensuring a master control structure is established. The above is a limited and time-consuming system. Similar to the power distribution, control distribution involves giving permission to individual machines to operate, while having one machine take charge of the overall sequence. The main machine in a sequence, often an independent conveyor system moving a product through an assembly process, verifies that all the machines involved in the process are in the safe for startup state. That is to say, all stops are functional through their normally closed contacts, and often they have returned to a neutral state or home position prior to startup. Each station or machine has their own 24-volt power to control the I/O within its sequence. When the MCR closes, it completes the circuit for the first machine's permission to run. Each corresponding relay will then get permission to run in sequence. If the MCR relay is turned off, all the machine cycle start relays will be lost as well. The permission chain is continued by using dry contacts on the start relays. A dry contact simply means the power flowing through the contact does not come from the same source as the relay coils. Above, the MCR relay coil shares power with the seal-in wet contact. Each subsequent relay's own power is switched on from the MCR or the previous relay in the chain. Each set of dry contacts is electrically isolated from the coil voltage of the triggering relay. When the MCR closes, the 24-volt for the machine 1 starter is switched on by the MCR's normally open contacts closing. Notice there is no sealing logic for machine 1 shown. In this way, all the machines are daisy-chained to the MCR. When a set of dry contacts on one relay closes, coil power is supplied to the next relay in the chain. Be aware, a set of dry contacts doesn't mean the contacts are voltageless. If the system uses 120 volts for its I/O, then 120 volts will be applied to the dry contacts. One of the greatest advantages the PLC has over relay logic is the power and labor savings created by reducing the number of real-world contactors used in the process. The top rung addresses the master control relay, digital output 00, and when true, digital output 00's coil would be energized, powering the master control relay. But the bottom rung has a contact from an internal virtual MCR. That is, there is no real-world contactor to maintain. It behaves logically, not electrically, and as such, it works like a real coil, as all the associated logic is solved and controlled as such. This means you can have an infinite number of relays, which is important when you have a limited number of I/O. While working on our labs, we will be using the MCR as a global variable that must be true in order for any program in our project to work.